all those things. Right, how to revise all those properties in 10 minutes. What I found that most of the property based upon this atomic radius. To understand this, you just remember one particular law, which is known as Coulomb's law. In that, suppose this is the charge Q1. You will study in electrostatic, and this is the charge Q2. Right? The force of attraction, suppose the distance between them is d. So the force of attraction or repulsion, it depends upon the nature of charge. If this is positive and this is also positive, similar charge repel, and unsimilar charge they attract. Suppose this is positive, this is negative, they will attract. If this is negative and this is negative, they will repel. Similar charges repel. So based upon that, Coulomb's law says that the force acting between the two charges depends upon Q1 and Q2, product of Q1 and Q2. And force also depends upon this. Here, as the value of Q1 and Q2 increases, the force increases. Here, the distance between them increases, the force increases or decreases in square. The force increases or decreases in square. You understood the meaning of this? Means small change in distance results in greater reduction or greater amount of force, right, acting between them. A very small change in d increases or decreases this force with a greater extent. In square it changes. So this is the Coulomb's law. Actually, when this Coulomb's law was devised or given, Coulomb didn't thought that it is applied in atomic level also. But we found that it is applicable in atomic level also. Right. Now, if you see the atom's structure, here it is, we have positive, that is nucleus, and electrons are revolving. This is positive and this is negative charge. So the force acting between the neutron and the proton is, electron and proton is force of attraction, because this is positive and this is negative. So always it is the force of attraction. How it is going to change? Suppose this charge increases. As the number of proton increases, the number of electron also increases. Means the value of Q1 and Q2 both increases. So the force of attraction increases. So when the force of attraction increases, the size means electrons are pulled towards the nucleus with a greater force. So the atomic size decreases. So what is your first if Q1 and Q2 increases, the force of attraction increases, hence the atomic radius decreases or the atomic size decreases. Right? Second, if the number of shell increases, right, so the distance between this and this electron increases. So the force of attraction which is acting on this electron will be decreased. Right? Hence atomic size increases. So if number of shell increases, atomic size increases. This is the basic of all these characters. Correct? Now see. How to summarize this? Okay. First of all, we should know what is metallic character or electropositivity. We define the metallic character with the electropositivity. And what is electropositivity?
To lose electron.
To lose. It is a tendency to lose electron. So, as the distance between them increases, right, the force which is acting on this electron is very less. So, the tendency of this electron to leave this atom is very high. Right. So this electron is loosely bounded electron. So its metallic character increases with electropositivity increases as the atomic size increases. As the number of shell increases, what will happen? The atomic size increases. So here the force of attraction between this and this decreases very rapidly. So this electron is very loosely bound. So its tendency to go out from the electron is very high. Right? So electropositivity increases. As the electropositivity increases, metallic character also increases. Because strong metallic character, any element which is having very strong metallic character, right, they are very good reducing agent. What is the meaning of reducing agent? So they provide electron very easily. Right? So this electron, because it is very loosely bound, so very small amount of energy is required to take away this electron. So it is very good reducing agent. Metallic character increases. You understood this? How this is playing a great role here? Okay. So as nuclear, we call this one as nuclear charge. As the nuclear charge increases, proton and electron both increases. Means Q1 and Q2 both increases. Right? So nuclear charge increases so what happens? See, atomic size is nuclear charge. As the nuclear charge increases, atomic radius decreases because the force of attraction increases. And this is true across the period. If you go from left to right across the period, what you will see? Number of shell remains the same. Suppose period number 3. In period number 3, all the elements having the same shell number. Shell number remains the same. But what you will see, what is increasing? Nuclear charge is increasing. If you see the periodic table, nuclear charge is increasing. Right? So as the nuclear charge increases, the atomic radius decreases. So atomic size is inversely proportional to the nuclear charge. And this is true across the period. Second is atomic size is directly proportional to number of shells. As the number of shell increases, atomic size increases. More number of shell, greater the atomic size. Greater the atomic size, greater the tendency to lose electron. Greater the tendency to lose electron, greater the electropositivity. Greater the metallic character. And this is true down the group. These are the two important points. As the nuclear charge increases, atomic size decreases across the period. As the number of shell increases, atomic size increases down the group. Even though the nuclear charge increases down the group, but due to the number of shell which is increasing, atomic size increases. Right? Now see the effect. First, what about the metallic character? What about the metallic character? As the metallic character or directly proportional proportional to as the atomic size increases, metallic character increases. Right? So, non-metal character as the atomic size decreases, non-metallic character,
Increase.
or if the atomic size increases, non-metal character
Decrease.
decreases. Third is electronegativity. What is electronegativity? It is the tendency to attract electron towards itself. Right? Electronegativity is related with the non-metal character. Right? So, this is same as this. As the atomic size decreases, non-metal character increases or electronegativity increases. Same as this. This is over electron affinity or ionization potential. Ionization potential is what? It is the amount of energy required to remove the electron from the isolated gaseous atom. Means when you remove one electron from the atom, you are making it what? Positive ion. So you require energy to remove. So ionization potential is atomic size. Greater the atomic size, lesser the ionization potential. Because greater the atomic size, so the electron which is in the outermost shell is very loosely bound. Are you getting it? It's very loosely bound electron. So very less amount of energy is required to remove that. So ionization potential decreases. Greater the atomic size, lesser the amount of energy required to remove the electron. Correct? And in the same way, electron affinity. It is also about the atomic size. What is the electron affinity? It is the amount of energy released when you add one electron to the isolated gaseous atom. Right? So, greater the atomic size, lesser the electron affinity. Means lesser amount of energy will be released. When you add electron into the isolated gaseous atom, greater the atomic size, lesser the amount of energy released. It means when you take a non-metal like chlorine, and if you add electron, huge amount of energy is released. But if you add electron in sodium, very less amount of energy is released. Right? You understood this? If you take potassium, cesium, francium, rubidium, as you try to add electron, less and lesser amount of energy will be released because metallic character increases, atomic size increases, and as per the atomic size, electronic affinity decreases. So, this is all, you can see all the property defined here with the atomic size. If you remember these two, you can remember all this. If you copy it, it is very fine. Still you have something to ask?
This is only the trick, sir.
This is only the trick. And by remembering this, you can